So hello, my name is Tommi, I'm from Finland, and I'm going to talk to you about this Reitit library today. And the title is Ancient Art of Data-Driven, and it's about this library and something we explored with doing data-driven systems. Quickly about me, so my computer career started in '83 with Sinclair Spectrum. It had this awesome 48 kilobytes of memory, and there weren't so many games, so needed to do some programming. But rewinding, fast forwarding to this 2012, when we co-founded Metosin, this company with Jarppe and Mikko. And nowadays, we have 20 developers in Tampere and in Helsinki. In Finland, we do projects, we have some startups, and mostly Clojure script, functional programming. And lots of open source too. Who has been using any of our libraries? Raise your hands. Quite a many, awesome. And then a small commercial. So there's this conference we have been organizing. It's the 8th in a row, Clojure Trie. So it's in Helsinki in September, and there's call for speakers open. So hopefully getting lots of of those, and hope to see you everybody there. It's students and diversity tickets are free, and there's the URL. I will put the slides into the internet right after this talk, so you don't have to copy anything. But this talk, so quickly, what is routing and dispatching? Then Reitit in two phases, basically the library and then the frameworks, and then something about the performance tuning we did, and then wrapping up. So what is routing? Yesterday, Tibor also talked about routing. So it's basically a really simple process of having this routing table and making lookups for that. So having a path and trying to find the match. And we have already really good libraries for Clojure. Ataraxy, BD, Composure, Kishma, Pedestal, Silk, Secretary. And I think I've used most of them. I haven't used Kishma, but all the rest. So they're all good, but and it's something we need when we do web apps. We do front-end routing, we do back-end routing, we can do routing in the message queue, and even databases. Postgres has this L3 extensions, which is basically a string routing table. We are using that too, that's awesome. Dispatching, what's that in this context? So after we have done a route match, there's usually some rules which are attached to that route, and we have to execute them somehow. There's this bunch of patterns, the middleware pattern used by Ring, nREPL, others. There's the Interceptor pattern, Pedestal, Reframe uses those. Kishma controllers, Tibor was talking about those yesterday. And you can use promises, whatnot. And it can be synchronous or asynchronous. So why should we do another routing library? We have already these good ones, but we wanted to explore this data-driven and go deeper with that. And for example, Clojure spec, it has been coming for 2 years, and now finally I think we know how we could use that and leverage that, so we would have the data and form for the data. And one other thing, performance. It was some of the libraries, I was performance tuning them and noticed that there's lots of hot air in the library, so wanted to build some library which would be really fast. And then the reach, many libraries, some existing libraries only work for JVM, some only on the browser, so just take all the best parts of existing libraries, add something new and create a library out of that. So, and build something try to build something fundamental, and who knows what is a yellow castle? Oh, I'm the only one? It's this one, so. It was my first Lego castle and still the best, so you can do anything with that, so it's like a fundamental thing. So all the bricks are really small, you can put them into any shape, even the horses. Horses are made of small bricks. So there's no surprises. If you want to make a horse with 2 heads, you can do that. Nowadays you cannot, they're just one piece. So small pieces, and you can compose them anyhow you want. But first, the library part. So Reitit is like a monorepo with lots of modules, and in the core there's this Reitit core, which is the engine of all. I will go through the features really quickly, but in the basics, the top-level API, there's only one function, which is called the router, and you create a router with that. And what you get back is this router protocol. And this is what you can do with that. You can match by path, name, and then you can ask what is the routing table. So that is important. So it's not a black box or some function which does something, but we want to, everything the router knows, we want to inspect that. And this is how you use that. You require this Reitit core, define a router, put some routes in there, and then you can do either this path matching or name matching. And what you get back is this everything the router knows about the thing. There's this data, which is the important thing. But if there would be path parameters, anything, so expose all the data, because we are programmers, we want to program with the data. About the syntax, Hiccup is a lovely syntax with the nesting and everything. So these are the two ways you can build the routing tables. These are exactly the same. And if you want to use nesting, this flows naturally. So the path, when the router is created, the paths are the strings and they're concatenated. And the route data, they are meta-merge. Meta-merge is this tool from Liningen originally. James Reeves put it as a separate library. It's the only dependency in the Reitit. So in top level here, we have the API. It has this route data, which is a map of interceptors. And it affects all these subroutes. There's an endpoint ping, which has a name. There's admin, which says that some roles are required, user endpoint, and DB. And when the router is created, this kind of internal format is created out of that. And as we can see, for example, the interceptors from this top level and this lower level, they are naturally composed with the meta-merge. And meta-merge has, it's like a deep merge with steroids. So there's this hints you can put, these merge hints that I want to override this value. So here, for example, it's by default for admins, but for the DB thing, it requires DB admin. As we can see, the DB admin stands, and here we use the default value. Programming routes, this is important because we want to do this. So little helpers, we are taking away the nils, and if there are sequences, we flatten them. So you can use for within the routing table, you can have these ifs, and if it returns nil, they're just removed. So this is how we want to use that. Composing routes, one of the libraries, we did Clojure API. This was the thing that everybody asked. I have these two routes, and I want to apply this middleware for both of them. But you cannot do that with Clojure because it applies the middleware in place. But here, it's just data, and we concatenate the path, so we can have these region-style or React-style empty fragments. So here, we don't add anything to the path, but we add route data to these routes. And as we can see, the route data gets merged into the endpoints. And if you have multiple routes, you can just create a new vector and put the routes in there. You don't have to know whether it was a single route or multiple routes because they are flattened. That's important too. And then, this is also when you're building a larger app, at some point your routes are all scattered all around. You have 10 namespaces, and suddenly there's some route which is not accessible, and you could actually put your routes, because it's data in Reitit in the Eden files, or even database have these multi-tenant user things. So is the routing table sound? And that's one important thing we wanted to solve. And by default, Reitit fails on these. So we have added this pretty printer, it's an exception printer, and try this routing table. So what happens? It seems that this user ID, orders, and bulk ID, at least this, if you try to ask bulk/orders, it matches both of the routes. So this is not a good thing. So what happens? So this happens. So this is the pretty printer. We use FIP and put this separate module. It would be nice to have this as a more common for normal Clojure, but it says the router creation failed, namespace user line 4, and these are the conflicting routes. And as we can see, there were many others. And then just don't try to be too smart. Just you can fix it by saying conflicts nil, and there's this awesome CLJ doc which has the documentation, and thanks Martin for that. It's easy to point it there into the current version. So, and if someone wants to do this kind of formatting, please contact me. We are happy to push it out. It was just an experiment, and it's now in Reitit as a separate module. So, but moving on to the data thing. So what is in the route data? It can be anything. So the router doesn't care. It's just a library. And when you do a match, you get the data back. And you can query from the router, so what are the routes and what is the data? And then you have to build some kind of interpreter for the data. And this is the route-first architecture Tibor was also mentioning yesterday. So first we match, then we get the data, and then we do something for that. And for example, this API admin DB, after a successful match, we can see the data. There's the 2 interceptors, and there's this 1 role. So now we should write some code which checks that whether the user has these roles and maybe apply these interceptors somehow. So, but it can be anything. And some things we have been using, and they are mostly part of the library. So authorization, you can add these role keys and say that these routes require some roles. In frontend, you can have views, so you can inline, like in React router, you can inline the components. So when this route matches, this is the function, or this is the React component which is relevant to that. So actually, you could build the whole front-end application into this one routing table, just like root, there's the root component. Dispatching, middleware interceptors, stateful dispatching with controllers, and for example, coercion with parameters and coercion. And some ideas, just like we could do more. I was trying to put this benchmark test, which needed I/O pools and dispatch pools, and thought that, of course, I will put them to the routes. There's one route which requires this I/O pool, which is, it's supposed to be really fast. So I could put them into route table, and just for the ALF adapter, just see that which routes need this, and put them into separate pool. And same thing, I think many of us are building these microservice architectures because customers want them. And at some point, they might see that, okay, this was not a good idea. We have these 10 small thingies, and development is hard. You have these 7 Docker containers running and runs out of memories. So idea is just put them into one routing table and just deploy them after that with these data. This is example from the nested view. There was a question about how to do nested views, which is a pattern in React router and in Vue. And Juho conjured this example in a few minutes. So normally in the front-end module, we use this view, which is a single view. But if you want to have these nested views, just invent a new key called views, and it's a vector of views. And here, for example, this is from the React example. So if you are in the topics, part of the your URL is a topic, then there's this topics view, and if it's topics/1, it's a vector of topics views and topic view. And these are normal React components, and in the topics view, you have this nested view, which just all the components take the match. And out of the match, it takes the next one in the view. So you can say that this is the placeholder where the child will be coming, and it was it's just data, so you can do anything with that. So it was really simple. But the bad thing is that you can invent these new keys. There was 5 minutes and there's views and everybody's happy, but now we have all the keys and we don't know what they are, and is it any more working? So is it too dynamic for its own good, data spaghetti? But we can use Clojure spec for that. The core allows us to put specs to the router level, which says that this is the spec that needs to be for all the routes. And spec will have these closed keys. There's just, I think Alex was blogged about it yesterday, but spec tools and spell spec have those already, so we can use them. So failing fast with missing extra or misspelled keys. Here's an example. Small router, we have defined the specs that the role is either admin or user, and roles is a set of these. And we have this one route, API admin, and it has a typo. Router has these hooks. We can set up the validation. It's not on by default, and we use the pretty exception printer. So what happens? You try to create a router, and this is what happens. So the mid part here is from Expound directly. So we just took the color scheme and made it lamer, so because we don't want to have Christmas when something fails. So, but it says that there's a typo, and this is really good. So if you define the specs, you get these fail fast errors. Another thing, the Bruce Haumann's spell spec, it has the close spec way of doing, and I added some extra for that, and now it's in spec tools, there's a functional wrapper on top of that, so we can take any spec and just say that close at with a function, and it closes that, and after that we get these typos also. So this is something that hopefully is coming to spec itself. Now we need the utility libraries. Failing fast. This is something that we want to do, and this is the way of doing that. Easiest thing, using a linter. There are good linters nowadays in Clojure. Before you have even compiled, you get the errors at compile time, development time. You can do those. At library level, in Reitit, we use this creation time. So we put all the things into creation time. When you create a router, we check huge amount of time. Huge amount of things, and so that we wouldn't fail at runtime, because failing at runtime is bad, and it's even worse that you fail at runtime at special occasion. For example, when the year changes and it just fails because of some misspelling. So don't do that. But this is where we can affect we can do something in the libraries, the creation time. Last part of the library part, the coercion, Déjà-vu, because I was talking about the same thing in 2014 about the schema was just arrived and it was new and everybody was happy. So we have coercion, and now there's spec, and now we almost have coercion. This is really nice. But in routing, there's parameters coming from inferior formats like strings or JSON, and we have the specs already and our schemas, and we would like to convert them automatically. So there's tools in spec tools at the moment, and discussing. Hopefully it's not in scope of Clojure spec, but hopefully it will get there. If not, we'll use the spec tools forever. But that was the library part, so you just call it and you have to apply the logic yourself. But then let's go to the frameworks. So difference between library and frameworks. In library, you call the thing, and in framework, it calls you. And to make things simpler, there's multiple frameworks in Reitit. These are all separate modules. So the Reitit ring for ring routing, Reitit HTTP, async interceptor thingies, Reitit pedestal, first-class pedestal support, and Reitit frontend, which has this simplified version of the schema controllers, history and fragment router, and lots of helpers. And just quickly, they all have basically the same features. I walk through the ring version. So small module, it adds request method-based routing. So basically, it takes a normal router and uses two of its extension hooks to make this compiler, which compiles the route data into this optimized lookup form, which supports these request methods and middleware dispatch. And then there's this top-level handler, ring handler, which takes a ring router and makes a ring application out of that. It supports synchronous and asynchronous ring, and it runs on JVM and in Node. There's a macchiato-esque example around. And there's no magic, no default middleware, so this is also this low-level library. So you don't get these one-liners which does everything. You have to set up everything yourself. That's important. Ring application, it looks like this. So we have an application. We make a ring handler out of the ring router, which has this small routing table API. Under that, everything has these two middleware, wrap API and wrap roles. Ping has this one so middleware is something which the ring router knows. The ping has this get endpoint. User has a middleware, DP middleware, some roles, some get and post interfaces, handlers, and then some default handler. And when you call it, it's just a function. So in the top, it's the normal ring handler. The thing is that it would be a black box, but the application has the router as a metadata. So you can ask from the application, what is the router behind you? And you can ask all the same information. So what are the routes? What are the middleware? What are the documentation? But there's this one thing. So who is reading this roles admin? So because this is a closed circle, you cannot just make a match and have some interpreter. So you have to have something which is reading this. So how do you do that? The simplest way is this. The match and the router are injected into the request because we first do the match and we know the exact chain what is there, and for those middleware we can for that chain we can push these. And the components can read them at request time and do whatever. This is kind of ad hoc way of doing that. And libraries like Kekkonen and Giada have been doing this for a long time. So the wrap roles middleware would be looking like this. It takes the handler, and it returns the ring handler, which takes the request out of that, takes the roles, which is injected by some other middleware, and at runtime it reads the match, data and roles and checks if the roles were required for this route. If not, if they were and the user doesn't have the routes, then it's forbidden, otherwise it works. And this is like kind of okay, but quite bad in the sense that like we are doing stuff at a request time and we haven't documented that anyhow. And the problem is that like Ring middleware, there's just functions. We don't know anything about that. So we have lifted them as like data. So it's a middleware record. There's a way to expand values to that. So you can have a keyword and there's a lookup for register. You can have a function which expands them. And you can, when it's data, you can attach documentation, specs, requirements. And when you use this in runtime, it's compiled into normal Ring handler function chain, so there's no penalty. And this is the same middleware rewritten as data. So it has a name, it has a description, it requires something. You can put this something which checks the requirements, but we just document that. And it has a spec that there might be these roles, but it's not mandatory. And the actual function is over here. That's nice, but we can go deeper. So we can compile, because now the fact that in this framework, each middleware knows the endpoint where it's mounted to, so we can do the same thing at router creation time. So when we create this middleware, there's this compile hook. It gets the route data which is it attached to, and the like options for the router. It's exactly the same, except if there are no requirements for the route, we don't have to mount the middleware at all, because there's nothing to check. We just return nil and it unmounts itself. So that's nice. Otherwise, it works exactly the same. And another nice thing about having this as data is partial specs. So this is a common requirement of what we have been doing. So you have to annotate all your routes. So there has to be some kind of security constraint. And for example, everything under account should have a role. So we can have this roles required middleware. It has a name, description, and a spec. It doesn't have anything to do with request processing. It doesn't have to do. Just like all the routes it's attached to has this partial spec. And if we turn on the spec validation, it requires that. So this routing table, the middleware we did, so we require roles. If the roles are required, it's checked for all the routes. It's a common behavior. This first route ping, it doesn't have any role requirements. It doesn't mount, so it's basically doing nothing there. Then all the account roles have this roles defined middleware, and in router creation time, it checks that all the routes have this role and it's valid. And the last one doesn't have, it fails. So you can have this thing that no one can add a route and just like without any security, like roles defined. That's nice. More things as data. So now each route has this the middleware chain. It's also data. It's the one vector. So we can modify that too. What can we do that? We can do reordering, completion, interleaving. And like one nice example is that we interleave this request differ. So between each middleware, we put this like pre-call and post-call, and pre-call just records what was the request before entering and what was the request after that, and we take a diff, and we print it to the console. And this is what it prints. So enabling that, it's a router option, this transformation function. So this parameters middleware, just like what it did, this using deepdiff, which is the Lambda Island, awesome library. It shows that this middleware added these three things into the request. And this is a nice thing, because at some point your chain is like 20 middleware long and you have no idea what is happening, and somehow somebody has slurped the body and like it's gone. And this is what you can do with that. Data definitions as data. This is like a stupid title, but the parameters. So schema is data, and like spec is not yet fully data, but there's this new select schema syntax, which is almost data, but we can use the data specs from spec tools and define these like parameter requirements. So for example, this is the open up API definition from basically Ring Swagger that everybody uses. The new thing is that it supports the spec nicely. So there's requirements for query, that's an integer x, and path parameter y, which is integer, and it will return 200 with body of total, which is a positive integer, and the handler like just sees the parameters as coerced automatically. And you have to put these middleware, so nothing, it's just data, but when you put this middleware, the middleware will say that these keys are allowed, and they will do the transformation. So everything is data, so just like go deeper there and just everything you can possibly imagine, put them as data and you get far. Really quickly, the Interceptor part is basically the same library, but runs with interceptors. You can use Pedestal for that, or Sieppari, which is a small library. You can use different async things. And you have to just hook this executor, which is running the interceptor. So this is example HTTP application run with Reitit. So same as the middleware thing, but you just change the middleware word to interceptors, and that's it, basically. And then you define what is the executor running that. And if you call that with 3 arities, so with the success and error callback, it's async, and you can return promise or core async or whatever. This is an example interceptor. This was a course request interceptor I was mentioning, which is doing the work. So all these internal components use this compile cycle, so they check that is there anything to do. And what is meaningful here for performance-wise is that in the compile phase, we pre-compile the coercers for that specific endpoint. Most libraries do that at runtime, and it's really slow. So runtime phase starts with this, so there's as small as possible runtime and as much as possible doing ahead of time. Small demo. Let's hope this works. Can you see anything? So this is from Reitit examples, this silly basic example about the HTTP thing. So in top, we have some specs, X, Y, total, some results with some metadata. We create this ring handler with this HTTP router. There's some routes, files, and here we can see that the meta merging, and concatenating path, it works nicely. So this Swagger affects these 2 routes. There's multi-parameter handling and some uploads. There's async, so just we use Sieppari here and manifold as for async here, so we used return deferred chain. We do some call to the internet and then return the response. And then there's the coercion things. And lots of interceptors, so there are no defaults. So the basic library is for builders. So if you know what you're doing, just use these. There's no surprises. You can take anything away. There's no defaults like in most of the stacks. Let's try to run this, what it does. Starting the thing. Something happened. Let's try to async. Do we have internet? That's interesting. We might have. Yes, so we got random people from internet. That's nice. And when we go back, we can turn on the request diffing. So there's this transform function. Let's put it on and recall that. What happens, it takes a bit longer because the pretty printer is not very fast. Here's the thing, what happens, lots of stuff. So entering, so this is for interceptors, but first enter, this is the context which was coming into the system. Then there's parameters, it added something there. Enter for content negotiation, it added other stuff. Request formatting, nothing. There's some coercion, added some parameters. The handler put it a response with all the data in. And I think in the end, the last step is leave from the body formatter, which takes the body and returns it with an input stream and says that it was JSON. So this is how it works. And now we have the closed spec function here. So let's fail this. Summary is what happens. It says that you have a typo. So this is good. This is a closed system, and we have defined all the specs. And if you make a typo, this is failing fast. Yeah, that was a demo. And so route-driven frameworks, routing and dispatching are separated. It can be middleware or interceptors, and we first do the match, and then we do the execution. And each endpoint has a unique chain, and because of that, we can compile the chain against the endpoint at creation time. We can optimize them, and we can apply the specs. And then the specs can there can be partial specs which only affect those routes. So these are the things we have built in here. And we get both the performance and correctness. And this is kind of nice. And my second part, my timer died. Do I have much time? 15 minutes, hopefully. I don't know. Okay, so second part, the performance. So this is like something that started with Clojure API. There were a few people asking, so can we make it faster? And I said, it's already fast. We don't have to do anything. And then I ran my first benchmarks after 3 years of maintaining the library. It was horrible. It was really, really, really bad. And first steps, like changing some middleware and some configuration, and suddenly it was 20 times faster. So if you're using Clojure API 1.1, please go to 2.0 Infinite Alpha. So it's like so much faster. Then there's this Reddit discussions that Clojure is slow. We went from Clojure to Go, so because of the performance. So actually the question is Clojure slow, and like what can we do? How fast or slow it is? Some things for measuring the performance. So we should always measure these micro and macro benchmarks. And in the end, if you get 10% faster, it doesn't matter. If you're doing compiler like ClojureScript, then 10% is awesome. But if you're doing like some kind of thing with I/O and 10% is nothing. But if you get order of magnitude better performance, then it matters. These are the tools I'm be using: Time, Criterium, awesome tools from Clojure Goes Fast, Async Profiler, and Decompiler. So simplest thing, time is the fastest way to do something. You just like try something and get some rough results. Criterium a bit better because it hots the cheat and gives better results. It's a bit slower, but that's really useful. And my favorite tool, the flame graphs. So it's a Clojure library. You just require this async profiler, start it serving files, and then run something, and the web server has this link for this SVG image which shows like what is happening. And that's an example from the merge. So Reitit performance, what we did. So idea was that Clojure API, it was like built somehow and try to make fast, and there was limits how far we can go, and Reitit just like take everything which is fast as possible and build on top of that. And like test that internally, test that against other routers, Clojure, JavaScript, Go, and these are the three things that like matter the most. Routing algorithm, most important, then the separation of creation and request time, and then the usual suspects. There's only one API for Reitit, but it has for the router, but internally it checks the best possible routing algorithm, and this is the current set of those. Lookup router, single static path router, therefore if it only has static paths, they are like making hash lookups or equality things, they're really fast. The Trie router is the most important, so if you have this complex wildcard structure, so I will go through how it's optimized. Then there's few of these special things, higher order routers, so quarantine router and mixed router, I don't have time to talk about those, but there's documentation of those. The Trie, that's interesting, so if you have non-conflicting trees with wildcards, the router will decide that it's case for trie. And like there's huge amount of tries. There's prefix tries, suffix tries, radix tries, like this hash array map tries, and whatever. There's like a huge amount of theory behind these. What is good for like routing in this sense is like a radix tree, modified version, and we have a Java-backed version of that. So it will be as fast as possible. This is the example. Routing tree with some routes, so version 2 routes, version 1 routes, and in the trie, this is something that users don't see, but I wanted to show that the internal trie first creates this abstract syntax tree and then compiles that. In ClojureScript, it compiles that into normal ClojureScript, and in Java, it injects Java code. And then there's this pretty function to view what it looks like. This is the end result. So it creates this routing tree where it checks by character where we are going. So first, the V is the shared for everything. It starts to walk there. If it finds a match, there's this if clause basically, or 1 or 2, and then it narrows down until it's found the match. And in Java, we can optimize it a lot. This is the optimization log. We have the benchmark. The fastest router in Go, HTTP router, 160 nanoseconds, this test. We started with 3000, which was like awesome, it's better than the previous ones. But then just like having these clueless efforts of trying something which works, and at some point realizing I have to rewrite this, and in the end it turned out to be like 190 nano, so it's almost as fast as the Go thing. This is the first version. I thought that this is like really good. It looks like idiomatic Clojure, and it must be like quite fast. So this lookup path is the only thing which is doing something. So we just have one if, another if basically, and one or. So is it going static route or dynamic route or catch-all route? And this was the like 1,000 nanoseconds, so 5 times lower. And this is the best you can do with my skills of Clojure. Flame graphing that way, lots of garbage, lots of persistent like operations. They are slow. They're much slower than like the mutable versions. Not good. And this is like after turning everything to Java, internal Java, so last steps. So everything is like optimized Java, and there are these few bumps. And what are these bumps? This is like, if you have a big bump, it's a slow thing. This is 30 nanoseconds, this is 30 nanoseconds. It's like the merge was 200, so we are in like really like in the last steps what we can take out of the performance. So 30 seconds, these are persistent hashmash ASOC functions, so we are putting the path parameters back. So that's like the dominant thing here. So we remove all those, we do it smarter way, and this is something like double reading the strings. This is the Java Trie, the last version. It looks like horrible, but it's fast. So like I was like coding Clojure in days and Java in night, trying to do this right. So that was strange. But there's Trie compiler, and we emit this kind of code. The usual suspect, this is the, like, I just collected some of the stuff which I know that, like, when you're writing, like, normal Clojure, these are the things that, like, if you take care of, you can get, like, easily many times faster performance. So persistent data structures, they're usually slow. You can use records or reified protocols. Multi-methods, they're also slow. You can use protocols instead. Map destructuring is slow in Clojure. You can use manually. That's a small thing. ASOC in and those recursive functions, they are also slow. If you have two ASOC, just say ASOC 1 and ASOC 2 with a threading macro, it's much faster. Generic functions like walk and zip, if you see a library which use walk in the request pipeline, like say to the author that this is really slow, it's too generic for anything, basically. It's powerful but slow. Dynamic binding, you have this one dynamic variable because you don't want to pass the variable down to the stack, and it's like easily 400 milliseconds, which is twice as much as the whole routing thing, so don't do that. Manual inlining, don't do that. JVM is much better at doing that. Regexps, they're also slow. So the numbers. So this is the current status of the routing thing. So this is the HTTP routing, 50 routes compared to the other Clojure versions. So it's 1 to 2 orders of magnitude faster. So in average, it routes 220 nanoseconds, and it's like 22,000 nanoseconds for the other libraries. And if you have really a busy site, it matters. If you are building an enterprise app, it really doesn't matter. It doesn't matter if you have 100 users, use whatever. If you are doing the next Netflix, you might want to try the faster ones. Another Google graph of the same thing. So the Reitit is the blue one in here. There's the other ones, you can see that the red one is a linear scan. It is fast by default, but it gets slower over time. This is pedestal. This green one, it's slow. It's fast all the ways. It's not as fast as the optimized version, but it's always fast, and it's good enough for many cases. And these are something is happening in the other libraries. I don't know what, but really strange behavior. It might be my test also, but this is the result. Looking out of the box, the fastest Go router, it's still 40% faster, so we have to do something. It's a good challenge. I know a few tricks to do. Not today. And then, does this still matter? We are talking about routing performance. It's one thing, and you have hitting the database, and you have this HTTP and JSON and everything. So does it matter? It matters. So most Clojure libraries don't even try to be fast. The README says that we want to be correct, and that's totally okay. But when you're building something that's supposed to be fast, and you take this default stack, for example, Composure, most used. Routing, ring defaults, I think most used middleware stack. You put them together and compare to Reitit. So with this 30-second load testing on my machine, so the default stack is 10,000 requests per second. And in Reitit, the same is with exact the same response is 50,000. And with small tunings, I got 110,000, which is it's saturated. I cannot go faster with my laptop. But there's actually a bit difference what it does. And the ring default, it's a huge stack of useful stuff which applies to all the routes. If you want one fast route there, you cannot do anything because it's always applied. In like architecture like Reitit, you can just have that default stack of middleware, and then, for example, this one fast route and say that exclude everything else. The silly benchmark, the TechEmpower, which compares these different languages. So the fastest, this is plain text. This is like silly test. So if you're using C++ or Go, you can have 7 million requests per second on this one Dell machine. And like the fastest version is in Clojure. It's really fast too, 4 million, so it's immutant. I have a fork of the immutant. I call it immutant Neo, and that's what I've been like playing with. Aleph is also fast. Then the other Clojure libraries, I don't know what they're doing, but there's a lot of extra things happening. Interesting is that I put this like mainstream Scala and Kotlin and like Elixir libraries, and they are not like really fast either. So the fastest Clojure libraries seem to be faster than those. That was really interesting. I didn't know that. JSON, another silly test. So fastest is the undertow Java version. There's the C++ C versions which are fast. Immutant. This is not a real number, so I just selected some of the tests. But we can see that immutant is like only 10% slower than the fastest routers, fastest things returning JSON. So we have a dynamic language, and it can be this fast. But the normal like Clojure libraries are way behind because they are doing too much work. And the last one, this is interesting. This is a real-life test with a database. So Jean Corfield is at the moment building this next.jdbc, and I'm trying to like contribute by checking some of the Reitit optimizations. And I have this library called Porsas. It means like a pig, fast as a pig in the snow is what we say in Finland. But this like test that how fast can we go with JDBC, because this Java JDBC is quite slow, and we both have got like this 10 times faster performance, and it shows here though. So the fastest Clojure library at the moment is like 4 times slower than the fastest other routers, and in other tests they are about the same. So I would say that we can make this twice as fast just by updating the libraries, and this is something that starts to matter because we are like a normal application is fetching something from the database, and if you have a market site which always fetches from the database, getting like 2 times the throughput just like with the smart libraries, with the same APIs. That's important. So we know that Clojure is really good for building web stuff, both in the front end and in the server. And actually, we found out that we can be really fast with the Clojure too. So this would be my like current like perfect stack for backend. So Aleph or Immutant Neo for the backend, they have this 0 copy request and Neo like streaming. Rate-based routing, it's clearly the fastest. Something fast formatting like JSONista, and then fast database library. We need good tools for async value streams. There are many of those, lots of other important components. But I think that if we just like take these best components and do something like a new stack out of this, we would have something like Scala has Play and Elixir has Phoenix, which are like everybody uses. They have like good properties, and I think we can build something for that also for Clojure. Some ideas. We have Ring, we have Pedestal, we have Yada, we have Friends, lots of choices. We have nice templates. We have examples. Should we have something like Interceptor spec? There's these islands of Yada interceptors and Pedestal interceptors and Siepari interceptors. There's this interceptor channel I summoned in the Slack, but it's not very active. Should we have something like a new reference architecture for the backend? Build something on top of that, these better, like simpler building blocks, and like making noise that Clojure is awesome because like if we are like as fast as the Scala things or twice as fast as Scala things, like I think people don't know that. I didn't know that. And then stuff like error formatting as a community, I think we should have them. And some kind of tooling for the data and inventory. So routing is just small thing of the big puzzle. So we are doing like everything with the data. So we have all the processes are defined in data, all the like use cases, and like we don't have any kind of way to visualize that. And for example, other tooling have these like developer UIs where you can register your own things and like see your data and have inventories of that. So we should build something like that. And like Clojure spec, I think it should be data. So we had the yellow castle. It was the like library thing, small parts. In top of that, I would say the frameworks. This is the king castle. I also have that one. That's also from the 80s. And then nowadays I'm playing with these castles. I have 3 lovely daughters, so these are the like easy building blocks. If you want to make a castle really fast, you want to do that. You don't want to do this. If you want to like Huntcraft your next Netflix, you probably want to stay in this level. So there are different castles we need. Last things. So next things what we are doing. Endless backlog of these things. Most marked with good first PR, help wanted. If you want to help us, please give us a hand. So Open API 3, everybody else has that JSON schema validation, everybody else has that Spec 2 supports when it comes out. Developer UI with remote debugger, it was supposed to be ready for this conference, we didn't have time for that. More batteries, guides, and then the fast JDBC thing. But wrapping up, so Reitit is a new library we have been building. But the big lesson is that like this data-driven design in the libraries and in your applications, that's the way to do it. And have like specs help you to validate and transform data. And because we have a dynamic language, we should fail always fast, and we can do that. And the performance, you don't have to be interested in performance, but if you do, and I say that I didn't know much about performance, but after deep diving here, I think I'm a better programmer because of that. I understand how it works. And if you're maintaining libraries, please test your libraries. They might be really slow, and there might be some small things which makes it really fast. And I think we can build beautiful, fast things with Clojure. So that's the URL for Reitit, and there's this channel in Slack to discuss. And that was my all. So thanks for listening. Is there any time for questions? Are there any questions?
Presumably I could pick out route, which is PLC file, use it. The same routing table on my UI and my backend.
So the question was that can you share the routes between the UI and the backend? And yes, you can. And there's examples in the Reitit documentation. So let's get the CLJ doc, if you find that. So yes, you can do that. And like there's ways you can put them there. And there's just like Reitit. Let's find it here. Reitit. How does it work? Shared routes. There's a shared route thing. So like you can use reader conditionals, you can use custom expander, and that's about it. But the documentation is here, and this is the Martin's like lovely thing. So yes, you can do that, and we do that also. Yep.
As we move towards more like data-driven configuration of applications, do you think that there's opportunities to break out some of the functionality that you put inside the like route data validator into a separate library that other people in the ecosystem could use, or do you think it's too specific per map?
Okay, so question was that could we take the data validation and other stuff out of Reitit into separate libraries? And like mostly they are, so that's the goal. So whenever there's something which could be like used elsewhere, we put it to other libraries. I just counted there were 70 libraries in Clojures from Metosin. So spec tools has most of the validation. So the like closed spec, spell spec integration, that's in spec tools. And the error formatter is now in Reitit, but I would like to be it somewhere else. So CLJ Common is a nice place to maybe host this. So if someone is interested, it only works. It only has this dark scheme at the moment that it works on, it's tested on my machine, so I don't know whether it works on Windows, and I don't have time to check it out. So, but yeah, definitely, we want to like, and if there's some need, just like poke us and we'll try to do good. Okay, I thank you for all. Thank you.